Solving exponential equations, Part 3. Solving an equation means to determine the value of the variable that makes the equation true. The problem with exponential functions is that the variable is an exponent. There are two methods that can be used to solve exponential equations. If the bases are the same or are powers of one another, then you can rewrite the bases, okay? Or if the bases are not the same or cannot be made into powers of one another, then you're going to solve graphically. Let's start with rewriting bases. Express each of the following with a base of 3. So, if you think about 81, that is 3 times 3 times 3 times 3, right? Because that's the same as 9 times 9. And of course, 9 factors into 3 times 3. How many 3's do we have there? We have 4 of them, so that's the same as 3 to the power of 4. 27 is 3 times 3 times 3. Remember that if you have a 1 or 3 to the power of 3, if you have a 1 over that, then that means you have to take the reciprocal. So that becomes a negative exponent. So that becomes 3 to the negative 3 all to the 5th. When you think back to junior high power laws, when you have a power to another power, you will multiply your exponents. So that becomes 3 to the power of negative 3 times 5, which is negative 15. Okay, if you have a square root, that's the same thing as writing it to the power of a half. Okay, so if I have 3 times root 3, then that's 3 to the first times 3 to the half. When I multiply two things with the same base, I'm going to add the exponents. So 1 plus a half is 1 1/2 or 3 halves. So that becomes 3 to the 3 halves all to the x. And again, when I have a power to another power, I will multiply the exponents. So that becomes 3 to the 3x over 2. Okay, 9 to the half. That means the square root of 9. So square root of 9 is just 3. Okay, square root of 81 is 9, which is the same as 3 to the power of 2. So if I have 3 times 3 squared, again, when I multiply two things with the same base, I'll add the exponents. That gives me 3 to the power of 3. Notice in each one of these cases, my base is the number 3 as requested. When solving exponential equations, if the bases aren't the same, but one is either a power of the other or both are powers of one smaller base, change them so that they are the same. Once they're the same, all you have to do is make the exponents equal and solve for x. Always verify the answers by substituting back into the original question. Okay, in question number 1a, we're going to solve for x. So, if you notice, I have a base 10 and the number 1000. 1000 happens to be a power of 10, and powers of 10 are easy because you just have to go by how many zeros there are. So that's 10 to the x plus 2 equals 10 to the power of 3. Now that the bases are the same, I can cancel them out, and I get x plus 2 equals 3, and I make my exponents equal to each other. Because if the bases are the same, the exponents have to be the same too. I'm going to subtract 2 from both sides to get x by itself. So, 3 take away 2 is 1. Substitute that back into the original question. 1 plus 2 is 3. 10 to the power of 3 is 1000. Let's take a look at part B. Now, they are not the same base, but I know I can make 9 into a power of 3. So, that becomes 3 to the 2x equals 3 to the 2 all to the power of x minus 1. Again, I'm going to multiply the exponents together, so I get 3 to the 2x equals 3 to the 2x minus 2. Now that the bases are the same, I can make the exponents equal each other. So 2x equals 2x minus 2. I'm going to get the x's on the same side by subtracting 2x from both sides. 2x take away itself is 0 equals negative 2. That's not possible. So therefore, this question has no solution. Okay, because that is not possible. All right, part C. Again, 8 and 1 over 4 are not the same base. 1 over 4 cannot be made into 8, but they both can have a base of 2. So 8 is 2 to the power of 3 all to the power of x plus 2 equals. 4 is 2 to the 2, so 1/4 is 2 to the negative 2, because again you want to take the reciprocal there, all to the x plus 3. Okay, again I'm going to multiply the exponents together, so that becomes 2 to the 3x plus 6 equals 2 to the negative 2x minus 6. Now you can get rid of the bases because the exponents are the same, because the bases are the same, and set your exponents equal to each other. So 3x plus 6 equals negative 2x minus 6. I'm going to add 2x to both sides to get x's on the same side, and I'm going to subtract 6 from both sides. So 3x and 2x makes 5x, 6 and negative 6 is 0, negative 2x and 2x is 0, and negative 6 and negative 6 is negative 12, and then we just divide both sides by 5 to get x alone. So x equals negative 12/5. Okay, and again you can type that on your calculator and just do a nice check. Part D, 121 to the negative x equals 1. 1's a special case, because remember that anything to the power of 0 equals 1, except 0. So we can rewrite this then as 121 to the negative x equals 121 to the 0. Looks like 121 degrees, but power of 0. Okay, now my bases are the same, so I can say negative x equals 0, and divide by negative 1, x still equals 0. Okay, and you can check again by substituting in 121 to the negative 0 is the same as 121 to the 0, which is equal to 1. Part E, I have 4 to the x plus 5 equals the square root of 32 to the 3x. Again, we want to use powers of 2 because 32 is not a power of 4, but they both are powers of 2. So I'm going to rewrite 4 as 2 to the 2, all to the x plus 5. I'm going to rewrite 32 as 2 to the 5. And remember, that's 2 to the 5, all to the half because of the square root, all to the 3x. Okay, so again, I'm going to multiply the exponents. So 2 times x plus 5 gives me 2 to the 2x plus 10. And 2 to the 5 times a half times 3x gives me 15x over 2. Okay? Now, because my bases are the same, I can cancel them out and equate my exponents. So I get 2x plus 10 equals 15x over 2. I'm going to times both sides by 2 to get rid of the denominator. So that becomes 4x plus 20 equals 15x. I'm going to subtract 4x from both sides. So 20 equals 11x. And then divide both sides by 11. So 20 divided by 11 equals x. All right, that's the answer to that question. Last but not least, letter F. Okay, 5, 25, 125. Okay, those are all powers of 5. However, I need to get rid of this coefficient first so that I can simplify that. So I can just divide both sides by that 5. So I get 25 to the x all to the half equals 125 divided by 5 is 25. Okay, so 25 to the 1/2 x equals 25 to the power of 1. So the bases are the same, so now I can make my exponents equal. So 1/2 x equals 1. Multiply both sides by 2 to get rid of the dividing by 2. So that becomes x equals 2, and that's all finished. Okay, so that is solving by equating the bases. Let's take a look at solving by graphing. Okay, so when you solve by graphing, again, there's 2 ways that you can do this, okay? You can graph y1 equals the left side, y2 equals the right side, and see where the graphs intersect, or you can rearrange them so that they're all on one side of the equal sign, and then figure out where they cross the x-axis, okay? So I'm going to do the first one by graphing each one separately, and on the second one I'm going to rearrange and just graph one equation. Okay, so let's graph 5 to the x first. we know it goes through the y-axis at 0, 1. Okay, and we know that when y is 1, that x is 5. Let's try that again. When x is 1, y is 5. 1, 2, 3, 4, 5. Okay, so there's the graph of, okay, y equals 5 to the x. Okay, I'll change my pen color here to graph the other one. So 3 to the negative x plus 2. So that's going to go through, let's see, 1, 2, 3, 4, up 1, goes through there, okay, and that goes through there, and that goes through here. Okay, and again, if you want to graph this on your calculator, make yourself a table of values to help figuring out what points I'm plotting here. It's probably not a bad idea. So that's y equals 3 to the negative x plus 2. Okay, as you can see, they clearly intersect right here. So you can use your graphing calculator to find the intersection point, okay? And that is at x equals 0.811, because remember we're solving for x, so you need your x value at that point. Okay, awesome. Now we're going to do part B. And again, I'm just rearranging that, so I'm going to bring this over to the other side by subtraction. So my equation I'm going to graph is y equals 4 to the negative 2x minus 3 times 1/2 to the 3 minus x. Okay, and I'm just going to make one big graph of the whole thing. And it looks kind of swirly, but it looks like this. Okay, and goes through there. Okay, and it kind of looks something like this. Alright, good. Okay, and again for this, we're solving for x. So when we graph this way, we want to know where the graph crosses the x-axis. So the x-intercept, you can use your calculator to find it for you, is 0.283. Okay, fantastic. That's done. All right, last example on this page. Many applications of exponential function can be solved algebraically or graphically. So we have a half-life calculation here with a radioactive particle, neptunium-235. It has a half-life of 400 days, which means after 400 days, only half of the original amount of neptunium-235 would remain. The rest of it has broken down into some subatomic particles and some other chemicals. Okay, so we have a sample of neptunium-235 with an initial mass of 500 grams. The amount remaining after x days can be modeled with the following half-life equation. So this is just a variation of our formula y equals a times b to the x, okay? All right, so a is your a naught. A naught stands for the original amount of the substance, okay? My multiplier, my base, is 1/2, which makes sense because we want to know how long it takes for half of it to disappear. Okay, and then my exponent is the relationship between how many days it takes for it to be gone versus how many days we actually have. Okay, write and solve an equation that determines the number of days until 125 grams remains. So that's our final amount. That's a to the x, a times x, or a of x. Okay, so let's sub in. A of x is 125. A naught is our original amount. We had 500 grams. Times 1/2 to the power of, t is what we're looking for, and my half-life is 400 days. Okay, now I'm going to, first of all, I need to get my whole exponential part by itself, so I'm going to get rid of the 500. It's because that's multiplied, I can get rid of it by dividing. 125 divided by 500 is 1/4. That equals 1/2 to the power of t over 400. Now, 1/4 is a power of 2, so that's the same, or is a power of a half, sorry. That's the same as 1/2 squared. Half times a half is a quarter. Okay. Good. And now that the bases are the same, I can make my exponents equal. So that becomes 2 equals t over 400. How do I get rid of dividing by 400? I do the opposite, which is multiplying. So if I times the top by 400 here, I'm going to times this side by 400 also. 2 times 400 is 800 days equals the amount of time before there's only 125 grams remaining. Okay, one last example, and then you guys are off to do some practice. Number 2. When diving underwater, the light increases as the depth of the diver decreases as the depth of the diver increases. On a sunny day off the coast of Vancouver Island, a diving team recorded 100% visibility at the surface, but 31.25% visibility 10 meters below the surface. At what depth will the visibility now be half the visibility at the surface? Notice that we can use the same half-life formula because, again, we are looking for half of the original amount. Okay, so we know that originally it's at 100%. Okay, times 1/2. Okay, and at a depth of 10 meters, okay, we know that there is 31.25% available. Okay, so how can we solve this? Well, first of all, I'm going to get rid of that 100 out front. So I'm going to divide both sides by 100. So 0.3125 equals 1/2 to the power of 10 divided by h. This one looks a little tougher, so I think I'm going to solve it by graphing. Okay, so just going to make a little rough sketch here. Okay, I can graph, so this is going to be 0, this is going to be 1, that's about 0.5. So 0.3125 looks right about there. So I'm going to graph that up as a horizontal line. And again, you can just graph this on your calculator to double check that I'm doing okay. You might have to change your window settings. Okay. And I'm also going to graph then 1/2 to the power of 10 divided by x in y2. So y1 should equal 0.3125 and y2 is equal to 0.5 to the power of 10 divided by x. Okay? And again, we're looking for the x value of where our two graphs intersect. Okay, so that guy's going to look something like this. Okay, so this is y equals 0.5 to the 10 divided by x. Okay, and we're looking for the intersection point, which is right here, and I need to know the x value, and x equals 5.96 meters for the light to be half the intensity, or half the visibility, sorry, as it was at the surface. Okay, great. So page 361, again, it's up to you how to solve the problems. So probably questions 14 to 16, if there's some problem solving there. Probably you can solve graphically, or you can solve them by equating the bases. However, if you solve graphically, as I did in this example, you need to make sure that you show a graph. Don't forget to show your teacher when you're finished.